Hello. Now let's solve this wave question we have before us. Now we have two questions before us. We have, in which region of electromagnetic spectrum is radiation of frequency 300 megahertz? That's question number one. Okay. Then we also have another question which we have here as: an electron has a de Broglie wavelength equal to the wavelength of X-rays. What is the best estimate of the momentum of this electron? Now, the first question is a question under what we call electromagnetic spectrum. I want to talk about electromagnetic spectrum, okay? Electromagnetic spectrum are progressive transverse waves which consist of electric and magnetic field, okay, oscillating at right angles to each other. That is, the angle which the electric field vector makes with the magnetic field vector is 90 degrees, okay? So that's why the vibration of the particles, okay, the vibration of the particles is perpendicular to the direction of displacement of the wave, and why that's why we have it as electromagnetic wave, okay? That's why we have it as electromagnetic wave, okay? So then also it is also electromagnetic wave because we know that electromagnetic waves are waves which consist of coupled vibration both in electric and magnetic field. So when it comes to electromagnetic spectrum of light, okay, or electromagnetic spectrum, now which frequency, that's what range, okay, what region or range, what region of the electromagnetic spectrum can we have radiation of frequency 300 megahertz? Now, okay, now let's look at it this way. Now we know that the electromagnetic spectrum can be arranged in order of decreasing wavelength and also increasing frequency. Now when we talk about decreasing wavelength, okay, now in terms of decreasing wavelength, we know that the typical wavelengths of electromagnetic spectrum, okay, range from the radio wave. We have the radio wave, which is of the order 10 raised to the power of 3, okay. We also have the microwave, okay, the microwave. We have the microwave, which can be given in the order 10 raised to the power of -2. Now we also have the infrared, okay, the infrared ray, which can be given in the order what, 10 raised to the power of -5. Then we also have the the visible lights. So for the visible light, okay, we can have this in the order 0.5 times 10 raised to the power of what, -6. Then also we also have the next one after the visible light, okay, would be ultraviolet ray, okay, ultraviolet ray. We have the ultraviolet ray, okay, which can be given in the order 10 raised to the power of -8. Then next to ultraviolet ray is the X-rays, which can be given in the order 10 raised to the power of -10. And the last one will be what? Gamma rays, okay, the last one will be gamma rays, which is in the order of what, 10 raised to the power of -2. Now these are the wavelengths, okay, these are the wavelengths, okay, the region for the different region. But when it comes to the frequency of radio waves, because I want to talk about radio wave, now the radio wave frequency ranges, between a few kilohertz, okay, to what, to 100 of gigahertz. So which means the frequency we are giving in this case, okay, which is 300 megahertz, lies within the what, within the what, radio wave region of the electromagnetic wave spectrum. All right, what I mean is that now the ranging frequencies, okay, the ranging frequencies of radio wave, okay, is between, okay, is between a few kilohertz, all right, a few kilohertz, okay, kHz, okay, to 100, okay, to 100, okay, to 100 megahertz, sorry, gigahertz, okay, to 100 gigahertz, which is, gigahertz. Okay, so which means any frequency that, that fall within this region, within kilohertz and gigahertz, we know that gigahertz is what is higher than megahertz. So that means the given frequency, the 300 megahertz, the frequency lies in the radio wave, region. Okay, it lies in the radio wave region of the electromagnetic spectrum. So this is the answer to question 1. So we just need to explain why this frequency, okay, the region in which we can have this frequency. What region can we have it amongst the what? Amongst the different regions we have in the electromagnetic spectrum. Now for question 2. Now this is question 1. Okay, we have the solution for question 1, and this is question 1. Now we have question 2. An electron has a de Broglie wavelength equal to wavelength of X-rays. What is the best estimate of the momentum of this electron? So we want to calculate the best estimate of the momentum of the electron. Now let's look at, because what is important here is to understand the question. An electron has a de Broglie wavelength. That means we know that de Broglie wavelength can be represented with what? Lambda. Okay, de Broglie wavelength is equals to Planck's constant over what? Over momentum. Okay, and the de Broglie wavelength, okay, that is electron has a de Broglie wavelength equals to the wavelength of X-rays. So that means that the de Broglie wavelength of the electron, okay, is equal to the wavelength of X-ray. Okay, remember I said H is the Planck's constant. H is the what? Is the Planck's constant. Now the value of Planck's constant is the 6.63 times 10 raised to the power of minus 34 joules seconds. Okay, so now we want to find out the best estimate of the momentum of this electron. So which means we need to rearrange this equation, so that when we rearrange the equation, we can now have the momentum to be h over what? The de Broglie wavelength. All right, so now what will now be the X-ray wavelength? Now, to find out the X-ray wavelength, we know that the X-ray wavelength is in the order 10 raised to the power of minus 10 to what? 10 raised to the power of what? Minus 12. So the average, that's the order, that's what we can have in between 10 raised to the power of minus 10 and 10 raised to the power of minus 12 will be 10 raised to the power of minus 11, because it is given in the order 10 raised to the power. That means it lies within this region. Okay, it falls within this region. So which means we can then what? We can now consider the wavelength of the X-ray. Okay, the wavelength of the X-ray to be 10 raised to the power of minus 11 meters. So we then plug in the values here. So we have P equals to 6.63 times 10 raised to the power of minus 34 divided by 10 raised to the power of minus 11. So that the momentum can now be 6.63 times 10 raised to the power of minus 34 plus 11. Remember, the unit of momentum is a kilogram meters per second. So we have the momentum to be 6.63 times 10 raised to the power of minus 23. Okay, minus 23 kilogram meters per second. So which means the momentum, okay, that is the best, okay, the best estimate of the momentum will be what? 6.63 in the order 10 raised to the power of minus 23 kilogram meter per second. Now don't forget that this is also the what? The formula for de Broglie wavelength, okay, which can be expressed as Planck's constant over what? Over, That's Planck's constant over momentum. Okay, remember, the noblest pleasure is the joy of understanding. Okay, bye bye.